Okay, so let's take a look at the home controller here. One thing to note I also want to quickly mention is that we don't have any unit tests for this project. Depending on the project you're on and the particular conventions that you're following when you code, it is often a good idea to write unit tests as you go, as you do refactor. And in the formal practice of refactoring, you would be writing unit tests. We're going to write unit tests at the end of this series and just treat this series as a high-level set of ideas that I would have if I were to come across a project that has some messy code, some procedural code that we would like to clean up. And so I'm going to write the unit tests at the end. So forgive me if I'm not writing unit tests as we go here. All right. The other thing that I'm going to do here is I'm going to essentially code as naturally as I would if I were coming at this as part of my job. And so this isn't really scripted. I'm just going to take a look through the various classes here and sort of clean as we go and see what sort of patterns reveal themselves. Okay, so I see that we have these string literals here. We want to make them a little more type safe. So what I'm going to do is create a class. And we'll move classes around once the dust sort of settles on some of these things. And I know that these are districts, so I'm going to call this class district. And I'm actually going to make this a static class. And then we're going to create an expression for each string that's a district and essentially name that thing. So we can say public static string Cambridge, and it's just going to be a simple expression that returns the value Cambridge, the string. And then we'll do the same thing here for downtown and county and then Middleton. And so why is this nice? Well, this is nice now because I can do things like this. District.Cambridge, district.Downtown, district.County, and district.Middleton. And anywhere else that these string literals were used or will be used in the solution, we now have access to a static class that just has an expression that returns their value. And so if it ever needed to get updated, we could update it all in one place. And this would, of course, evaluate to the new value everywhere that our static invocation was used. Okay, so the other thing that maybe we can do here is inside of this static class, we can have a public static list of strings, and we can just put these values here. And we'll call these districts, or maybe just all, or something like this. And so in this case, this could be useful for us because now rather than have districts here, we can just say district.all, and now we select our new select list item from this. I'm just going to clean this up a little bit. And if all isn't descriptive enough for us here, we can rename it as well, like standard districts or something like that. Really whatever makes sense for your particular business logic. And we can actually make this an IEnumerable instead of specifically have it be a list. And it's also the case that if for some reason we only ever use the districts sort of in aggregate here, then we could make these expressions actually private. That is if we didn't have something like district.Cambridge on its own outside of using it again in aggregate here. But in fact we probably will, so I'm going to leave these as public for the time being. And now, for now, I'm going to move these. We could move them into the models directory here, but this is really in an MVC project. Again, typically you'd have different class libraries here for the different, for like the service layer, for instance, and the web layer, and the data access layer. And in this case, this type of helper may actually exist up in the service level. And so what I'm going to do is inside of the services here, I'm just going to add a directory called helpers. I'm not always a fan of creating helpers directories because they kind of can be junk drawers, but we have a really small app here, and so for now I'm going to do just that. We're going to call it district helper. And then we're going to place this class in this file. Import those missing references, which is just system collections generic, and now we use the new namespace that we have here. So now we're using refactoring web services helpers. I'm going to go ahead and remove the unused reference. And now we have sort of extracted the responsibility of getting those districts to a helper class here, and we'll be able to use these more type-safe values everywhere in the application where we need them. Okay, so this is a pretty boring controller, and I think I'm going to leave it here for now. What we'll do is we will move into the other controller, which happens when we make that post request. And so we'll go into our controllers, into the order controller, and here we have a little bit more of an interesting thing going on. First of all, I can see immediately that we're newing up an order service directly in the controller itself, and that is not exactly what we typically want to do. Additionally, I can see that we're setting some essentially a value, an object that's tracking a value here, a DTO if you will, on the order service as it's instantiated, which also often raises a flag for me that this service isn't stateless. And typically when we have service level classes like this, we want their constructors to declare their dependencies and not to take objects like this, which essentially they are in charge of mutating and then responding to requests for the current state for. You can get some really subtle bugs and things that are very hard to change if we're depending on this order, which we can see is created outside of this context, then is changing under the hood here, and we really have no way of understanding what it's doing, particularly if we have multiple levels of abstraction that are handling it. So let's deal with one thing at a time. The first thing that we're going to deal with here is using dependency injection to actually handle instantiating our order service. So the first thing to do is to actually extract an interface. And so with the IDE here, we can extract an interface very easily. You could extract it using ReSharper, or I'm using Rider in this case. And probably Visual Studio may have a way to do that as well on its own at this point. But what we have is just we're extracting the public methods from order service into an interface. And so now we have an iOrder service interface. And what I'm going to do here is in the services namespace, I'm going to create a directory here called interfaces. And I'm going to add the interface iOrder service to this. Then we're going to take this interface definition out, and we're going to put it right here. Order, we're going to import the missing references that we need. Come back here, and then import that reference here. So now our order service implements iOrder service. And what I want to go ahead and do is in startup.cs, or excuse me, in startup.cs, and then in services here, this is where we're actually going to wire up those dependencies. And so what we're going to say here is in configure services, we're going to say services.add transient iOrder service, and then order service. So what is this doing? This is .NET Core, the framework essentially saying anytime in this assembly when we, or anytime in this particular web project, when we have an iOrder service passed as a parameter to a constructor, we're actually going to instantiate an order service implementation. And so if we come back to the controller here, and we make a constructor for the controller. So let's make a public order controller. We're going to pass this controller parameter, or this constructor parameter, an order service, iOrder service interface. And then we'll create the backing field for that. And then anywhere that we have an order service, we can actually use the value that the framework is going to wire up here. So note that nowhere in our project are we ever going to say something like new order controller. That is the responsibility of the framework to create as an HTTP request comes in. And when the framework now sees that that an iOrder service is being requested, it's going to wire up the implementation that we've defined in the so-called dependency injection container. And you'll find that if you're new to DI, there's a lot of terms that come in like container, the principle of inversion of control. Really, the key thing to keep in mind is that inversion of control is the pattern that we want to implement using dependency injection. And in particular, we'll be using something called constructor injection. And the whole idea is that rather than using the new keyword everywhere and newing implementations up inside of the scope where they're used, we're always instead going to essentially pass something that defines the behavior of such a thing. And in C# here, we can make use of interfaces to do that. And so what's happening is the framework is saying, okay, at runtime, when you ask for an iOrder service implementation, I'm going to bind an actual order service to it, essentially as late as possible. And so this is late binding, if you will, to use, I suppose, another fancy term. We are essentially defining the particular implementation of a thing that we want essentially at the very end of everything. We want our code to essentially, we want to code to behavior. We want to code to an abstraction rather than an implementation, and then the implementation itself is wired up at the latest possible moment. And so we'll see how this actually allows us to write nice unit tests for things like this, particularly when these services do things like make I/O calls, like make network calls, or try to connect to databases, request things from third-party APIs over HTTP. We can actually unplug all of that stuff by creating mock versions, if you will, of these things in our test setup, and then test the business logic around them so that we can really test the behavior of methods without wiring them up explicitly to anything like a database or an actual network. Okay, and now as soon as we do this, you may be asking, okay, that's great, but the order service that I'm newing up here has a constructor where we're passing in an order. And how are we going to use this backing field if the framework itself is creating an order service for us? Doesn't the order service here need to know the value of this order object to get created? And the answer here is that this is the wrong way to do it. Essentially, we can make this much more functional by asking ourselves, when does the order service need to know the state of this order? And the answer is it doesn't need to know it when it's created. It needs to know it when it's working on it and processing it. So what I'm going to do here is we're going to simply remove this constructor. And well, we can leave it here for the time being, but I'm going to make a new constructor called order service. And we just mentioned that the role of a constructor should be to declare the dependencies it needs in the form of abstractions. So let's take a look at what order service depends on. Well, it depends on this Chamber of Commerce API, and we can see it also depends on this deal service. So anywhere where we're newing up some class that has some behavior that we're depending on, this is what we mean by the things that order service depends on. Now it's also newing up this advert, but we can see that this is actually just a sort of DTO that holds some values. It doesn't have any behavior itself. So that's not really a problem, but we do have some problems with our Chamber of Commerce API and our deal service being newed up in this class. So what I'm going to do is I'm going to head into deal service, and we're going to create an interface for this. Select the public members, come into interfaces. We're going to add an interface here, ideal service. And I'm going to just take this interface out, put it into the new file that we just created. import the missing references to system in this case, and now import the namespace for ideal service. And while we're in here, I can see that deal service doesn't have any external dependencies of its own. We do have some refactoring we can do here with the primitive obsession or the literals of strings here. We can definitely clean that up later, but let's just focus on the dependency graph for the time being. And we can see that we can have an empty constructor here, and deal service doesn't really need to depend on anything else to do its work. So we'll come back. And now iOrder service, we can say, requires the behavior of a deal service. We'll create a backing field for this. And then we'll come to startup, and we're going to add a transient ideal service. So this add transient, there's a few other things that, a few other scopes that we can add here. One is add singleton. If we add a singleton service, that's going to last for the lifetime of the application, which in the case of a web app is the lifetime of the web app. And so a lot of times we don't want to do that. We really just want the behavior of a service scoped to the HTTP request. And so anytime there's an invocation of this service and it's used, it's going to be disposed at the end of that execution path, at the end of the request. And so for that, we can scope it using add transient. And I'll post the link in the description to the various other lifetime scopes that are built in. So there's our controller with the order service, but we still have our old constructor here taking an order, so we'll address that momentarily. Now we can see that the Chamber of Commerce API is static, and it's a static class with static methods. And so in order to create an interface for it, we're going to need to make it a non-static class. So we'll do that, and then we're going to extract an interface for it here. We want this to be an instance method so that we can create an instance of iChamber of Commerce API and wire it up. So now we'll create an interface. iChamber of Commerce API. Okay, so we'll take this interface out, plop it down here, import the system.threading.tasks, and then import missing references here. Note that in C#, when we declare the interface for it here, we don't say async here, we just say task. And then when we create the implementation of the method, we do need to put the async keyword here in order to await asynchronous calls within this method. Okay, so now we need to make sure that the Chamber of Commerce API gets wired up when our app is set up. So we can say iChamber of Commerce API. Notice also now that if we have some major feature request in which, let's say, the Chamber of Commerce API gets a complete overhaul, we can work on another class that implements our interface completely separately of the one that we have. And when that's complete and we want to start testing it, we can just swap out the implementation here with the new one. Now, I wouldn't necessarily recommend naming it New Chamber of Commerce API, but you get the idea here that since the implementation is only wired up as late as possible, essentially we can continue using the existing implementation and just very easily swap out the new one, because throughout the application itself, we're only ever requesting something that implements the behavior of the interface. So there's never going to be a new Chamber of Commerce API written anywhere in the code base. Okay, so now we can't make this static method call, of course. So let's go ahead and complete our constructor here, iChamber of Commerce API. We'll create our backing field. And those, of course, can be read-only. I'm going to clean up the way the constructor looks here for a bit. And now, rather than, let's take our deal service for instance, rather than we have these new deal services everywhere, what I'm going to do is just remove new deal service, and then this is going to break everything until we replace it with the backing field deal service. Now I know there's a lot to clean up in this enormous if-else block, and we can use polymorphism and some OO principles to do that, but for the time being, let's just focus on one thing at a time. So do we have any other deal services in this class? We don't. Okay, so now let's take care of wiring up the Chamber of Commerce API properly, because this is no longer static. Okay, so just two places where that's done.